This is problem 1 from exam 1 of module 2 in the book Problem Solving Guide for Mechanics and Thermodynamics. Problem 1. A person runs off the edge of a vertical cliff above a quarry with an initial speed of 6 meters per second horizontally. This cliff is 20 meters above the surface of the water. How far is from the base of the cliff will the person splash into the water? So here's our diagram. Let's put the speeds in there. And it's a good idea to put the vertical and the horizontal to differentiate. The initial speed in the y direction is 0. Initial speed in the x direction, 6 meters per second. The height's 20 meters. Now let's think, what's going to happen here? As soon as he leaves the cliff, he's going to accelerate downward, 10 meters per second each second. He continues at the horizontal speed of 6 meters every second. We can use the vertical direction to figure out how long it's going to take him to hit the water. And then once we have that time, we can just say it goes 6 meters every second for this long, and we can figure out the horizontal distance he travels while in the air. That's our strategy. It's certainly tempting to think, students make this mistake all the time, has to fall 20 meters. The acceleration due to gravity is 10 meters per second each second, so therefore it's going to take 2 seconds to hit the water. That's bad reasoning. Let's check it. The initial speed in the y direction is 0. The person accelerates 10 meters per second every second in the y direction. After 2 seconds, it's going 20 meters per second downward. Starts off at rest in the y direction. Accelerates 10 meters per second every second. Since he started with a vertical speed of 0 and ended up at 20 meters per second, his average is 10. If you average 10 meters per second for 2 seconds, he travels a vertical distance of 20 meters. Wait a minute, it worked. How come it worked? It's not supposed to work. That's bad reasoning. Let's check a different height. If the height is 30 meters, is the time to fall from rest 3 seconds? Using similar logic, that would be the case. After 3 seconds, he's going 30 meters per second. All right, starts at rest, gets up to 30, the average is 15. If you average 15 meters per second every second for 3 seconds, you go 45 meters, not 30. So it takes less than 3 seconds to fall 30 meters. The faulty reason gave us the correct answer in this one case when the height is 20 meters. So we have the equation v final squared in the y direction equals v initial squared in the y direction plus 2a sub y. In this case, the initial speed is 0 in the y direction, so we just have 2a sub y, and when the acceleration is 10 meters per second squared, the 2a gives 20 meters per second squared, and y is 20. So coincidentally, it works only for 20 meters. So it's a good idea to determine the time it takes an object to fall from 10 meters when it's dropped from rest. How long does it take an object to fall 10 meters when dropped from rest when it's accelerating at 10 meters per second squared? It ain't 1 second. And when the professor says it's a good idea to determine, that's a strong recommendation. You should probably pause the video and calculate how long it takes an object to fall 10 meters when released from rest. So back to this problem. The time to hit the water after leaving the cliff is 2 seconds. We got that. Let's check it. Let's just make sure. Y is 1/2 a sub yt squared plus v initial yt. It's always good to practice. Y is minus 20 meters. It fell 20 meters down. Acceleration minus 10 meters per second squared. V initial y is 0. So we just put the 2 on the other side, put the 10 on the bottom. Take the square root, 2 seconds. All right, now I'm happy. Think about it a different way. Don't plow forward. So the person's going 6 meters every second in the horizontal direction, and he's in the air for 2 seconds. He's going to go 12 meters. That's the answer.